Okay, this is in a lot of ways similar to the last problem, but it was different enough that I thought I'd give you an example. So it is a pool that's being filled by an inlet it takes, if the inlet's open, it'll take the inlet 12 hours to fill the pool. If the outlet's open, and just open, if they close the inlet and open the outlet to empty the pool, it'll take 16 hours. So it takes a little bit longer to empty the pool than to fill it. Now, I don't know why they'd want to do this, but the question asks if the pool is 2/3 full, how long will it take to fill it if both pipes are open? I don't know why you'd be emptying a pool at the same time you're trying to fill it. Usually they empty it and then fill it. But this is a math class, so it doesn't totally have to make sense, right? All right, so here's the tricky part, and this is why I chose this particular example, because because of the fact that it's already 2/3 full, hang on, let me get my smart board to act correctly. Because it's already 2/3 full, then we're really interested in how long it's going to take to fill 1/3 of the pool at these rates. So we're going to take the rates and multiply them by 1/3. And 16 by 1/3 is not a very satisfying number. It's just 16 over 3. Now, similar to the last problem, what we do is, and there's also a problem like this, I think, in the assignment. What we do is we set up this little equation, and it basically says that if we're if it takes 4 hours to fill that 1/3 of the pool that needs to be filled, and remember, since it's emptying, we're going to subtract the 16/3. So we're looking at rates here. You know, how long? Well, we're looking at rates in order to solve for time. So what we're going to do is take the emptying amount and put it in the bottom of the fraction, and then that's going to be 1 over t. Okay, now we have a rational equation, but the first problem is I've got what we call a complex fraction. I've got a fraction in the denominator of a fraction. So I'm going to simplify that. I'm going to do this in the margin here. 1 over 16/3. If we think about that large fraction bar beneath the 1 as division, one way to look at this is 1 times 3 over 16. We flip the second fraction when we divide. So that just turns it into 3 over 16. So here's my simplified equation. And I'm going to solve this by clearing the fractions. So my common denominator here is my least common denominator is going to be 16 times t. 4 will go into 16 evenly. So I'm going to multiply this whole thing by 16t. And I'll get 16t times 1/4. So 16 divided by 4 is 4. So this will give me 4t. And 3/16 times 16 over t, the 16s will cancel. And I just get 3t. And on the right-hand side of the equation, the t's cancel, and I'm left with 16. Well, this turns out to be a really easy equation to solve. 4t minus 3t is just 1t. So if they have both pipes open, both the inlet and the outlet pipe, then it's going to take 16 hours to finish filling that last 1/3 of the pool. All right, we're done. See you in class.